Okay, so here we go. We've got the coin problem here. We've got 35 pennies lying on a table in a completely dark room. 12 of them are heads up. The other 23 are tails up. Suppose you are unable to feel which side of the penny is which. You can move them and turn them over. How can you separate the coins so there are two groups of pennies and there are the same number of heads up coins in each? Every semester I choose a problem that I think is difficult for my students to do. This happened to be the difficult problem from fall of 2020. When I first read this problem, I didn't know how to do it. I thought I could visualize it in my head. It turns out I couldn't visualize it in my head. And not only that, I failed to relate it to a similar problem that I did know how to solve. So eventually I ended up using resources outside of myself to solve this problem, which is what I would guess a lot of students will do, but I don't know. So let's go through it. Let's go through one way we could get there. I was going to actually act it out. So I went and found some pennies, but I realized that they wouldn't record well, and I didn't have a bunch that matched. I certainly didn't have 23. So instead of using pennies, and this is what I do whenever I can't find enough things, I've got some manipulatives. Okay, what I did is I just took some pieces of paper and cut them up. I wrote tail on one side and head on the other. And instead of doing 35, I cut out 12, but I'm going to use 11. So here I've got my 11. I'm going to zoom my camera here. Here I've got my 11 pennies. And let's suppose we have 3 of them that are head up. So all I can really do, since I'm in this dark room, I can't feel which side of the coin is which, is I can take some group of these, separate them, and then flip them over. Okay, I can do that as many times as I want, and so you might think, well, maybe if I grab, one of them and flip it over. Well, that can't be right. I've got an odd number of heads, so I'm going to have to flip over at least as many as I have. So you think maybe if I flip them all over, it won't work because I'll just reverse them. If I take half or one less than half or something. The key here to home in on is the only numbers we're given besides how many coins there are is how many heads and tails there are. So in fact, if you take 3 of these coins and separate them out and then flip them over, here I've grabbed all tails, but now I have a group of 3 heads, and I have 3 heads in my original group. All right, so you say, well, that'll work if you get all tails. But look if I grab one of the heads and 2 tails. When I flip these over, now this group has 2 heads, and this group has 2 heads. Similarly, if I grab all 3 of the heads and flip them over, this group will have 0 heads, and this group will have 0 heads. So, and messing around with that and then extrapolating. So I've got manipulatives here. I'm also going to use inductive reasoning. If I add in another coin and say it's a head, now I want to convince myself if I take any 4 of these, I'll end up with 2 piles that are equal. And in fact, I will. So I can even mess them around, and I'm not going to look. If I grab 4 of these, you can't see, but I'm not looking at what I'm doing, which makes it much harder. Okay. I grabbed 4, these 4, let's say, and if I flip them over, I've got 2 heads in this pile, I've got 2 heads in this pile, so it will work for this number, which means it should work for 35 pennies with 12 of them face up. I'm going to take 12 pennies, move them to a separate group, and then flip those all over. So once I've flipped those over, I'll have the same number of heads in this group and in this group. The 2 problems that I couldn't link to this that I should have, if you have a deck of cards and you split it in half, you split hearts and diamonds in one pile, or in one half deck, and clubs and spades in the other half deck. If you take 5 cards from the red cards and put them in here, shuffle these, take 5 cards from here and put them back, there'll be as many black cards in this deck as there are red cards in this deck, because all you've done is move them back and forth. Similarly, there's a question about water and wine. Take a teaspoon of wine and put it in the water, mix it up. Anyway, there are related problems. I couldn't grasp it the first time I did it. I did have to look up the solution to this problem the first time I encountered it. But when I was looking for problems, I remembered, oh, what about that coin one? So I remembered it, I remembered the solution, and I was able to write it up. So that's the solution here. You take the same number of coins as heads, put them in a separate pile, flip them, and you'll end up with the same number of heads in your two separate piles.